Hi all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video lecture series, let us see about different cellular networks. The first network is GSM network. So GSM network is nothing but a global system for mobile communication. So it is a digital mobile network that is widely used by the mobile phone users in Europe and other parts of the world. GSM uses a variation of time division multiplexing access and it is used in 2G networks. It is most widely used in three digital wireless telephony technologies like TDMA, GSM, and code division multiple access. Mm, See, it digitizes and compresses data, then sends it down to a channel with two other streams of user data, each in its own time slot. It operates at either the 900 megahertz or 1800 megahertz frequency band. So this is a architecture of GSM. So here GSM together with other technologies, it's part of the evolution of the wireless mobile telecommunication that includes high speed circuit switched data. Uh, so GSM network, it consists of mainly four separate parts. One is the mobile phone itself, then the base station subsystem, then network subsystem and operation and support subsystem. So if you see here, you'll be having a mobile phone. So this mobile phone, it will be connected to a base station subsystem where in turn it is connected to the network subsystem and finally operation maintenance comes here. So let us see each one by one in detail. So the four main functional units are mobile station, base station subsystem, network switching subsystem and operation support subsystem. So first one is the mobile station. So the mobile station include your mobile phone device as well as your SIM card. So the SIM card you'll be having the IM as a number. That number is very important. So based on that number only your subscriptions, your billing details, everything will be monitored. So without a SIM card, you cannot use a mobile phone. So you can replace the SIM from one mobile phone to another mobile phone whenever necessary, and all the data can be transferred between different mobile phones. So here also you'll be having mainly three other services that will be used, which is the voice teleservices, data services and the supplementary services. So voice teleservices are nothing but our communication between the sender and the receiver, voice communication. Next one is the data services, nothing but all the messaging services, whatever we are using, voice message, data message, emails, all these will come under your data bearer services. The next one is supplementary services. So call forwarding, call waiting, call blocking. So all these extra additional services comes under the supplementary services. So the mobile station also provides the receptor for SMS messages, enabling the user to switch between the voice and the data. The mobile station is also provides access to various other data services which are available in the GSM network. So high-speed data switch, circuit switch data at the speed of 64 kbps is possible here. So next one is the SIM card. So SIM card, it provides personal mobility so that the user can have access to all the services which are subscribed irrespective of the location where he or she is present. So you need to insert a SIM card into any GSM mobile phone in order to receive the calls at the phone, make the calls to others and receive all the other services to which we are subscribed. Next one is the base station subsystem. So under the base station subsystem, we have two parts, which is the base transceiver station and the base station controller. So the base transceiver station and the base station controller, they communicate with each other using an interface known as the abyss interface, which enables the operations between the components that are made by the different suppliers. So the radio components of the base station subsystem, it can consist of either 7 or 4 or 9 cells, so that a base station subsystem may have one or more base stations. So all the base stations are together to be connected to the base station controller. So the base station controller keeps monitoring the base transceiver stations. So a separate high speed line, T1 or E1, is then connected from the base station subsystem to the mobile switching center. So this is a diagram which shows the base transceiver stations. So normally we'll be having mobile phone towers near our houses. So these towers are nothing but the base transceiver stations. So these base transceiver stations consist of number of antennas, which are the nothing but the transceivers, which are used for transmission and reception of the information. Um, so in large urban areas, a large number of base transceiver stations may be deployed. So the coverage of these base transceiver stations depend upon the height of the antenna, transmitting power of the antenna. All these are a very important factors that are necessary to determine the coverage of the radio coverage of the base transceiver station. So as shown in the diagram, the base transceiver station is connected to the base station controller using an abyss interface. And from the base station controller, you will be connecting it to the MSE using the high speed T1 line. So the base transceiver station is usually placed in the center of the cell. Its transmitting power defines the size of the cell. So each base transceiver station has either between 1 and 16 transceivers, depending on the density of the users in the cell. Apart from this, there are several other functions that are performed by the base transceiver stations, like encoding, multiplexing, encrypting, modulating, then feeding the signals into the antenna, time and frequency synchronization, decoding, decrypting, and equalizing the received signals, uplink channel measurements, random access detection. All these are additional functions that are performed in the base transceiver station. Next one is the base station controller. So the base station controller manages the radio sources for one or more BTS. It handles radio channel setup, frequency hopping, and handovers. So base station controller is a connection between the mobile and the mobile switching center. Uh, the BSC also translates 13 kbps voice channel used over the radio link to the standard 64 kbps channel used by the public switch telephone network or ISDN. The function of the BSC is to allocate the necessary time slots between the BTS and the MSC. It is a switching device that is used in the radio receivers. So additional functions include the control of frequency hopping, providing an interface to the operation maintenance center for the BSS, performing traffic concentration to reduce the number of lines from the MSC, then time and frequency synchronization, power management, reallocation of the frequencies among the BTS. All these are taken care of by the base station controller. So next one is the network switching subsystem. So as shown in the diagram, the network switching subsystem consists of many registers like VLR, HLR, EIR, and AUC, where VLR is nothing but the visitor location register, HLR is home location register, EIR is equipment identity register, and authentication center. So home location register consists of the data where the user is registered in its own area. So it consists of all the informations about the user, like the IMEI number, IMSI number, what subscription the user has subscribed, so what are all services he can use. So all the entire information, location, address, so all these things will be stored in the home location register. In the visitor location register, you'll be having the information of a user who is under a temporary condition. Like say when you're going in a roaming state, so your mobile will be registered as a visitor in the new area. So where the visitor location register will be having the temporary data of the user. So the visitor location register will identify the new user and will get the data of that user from the home location register, and then it will be using it. Next one is authentication center is used for privacy and security purposes, and equipment identity register consists of the IMEI number, so it is used to find out the mobile phone under the cases of theft and so. Um, So next one is the operation support subsystem. So here it comes the maintenance and operation of the entire GSM. So here the functions are administration, commercial operation. So it will be in the operation maintenance subsystem only all the billing and subscription details, all these things will be present. Security management will be done here, and also the network configuration and performance management and the maintaining of the task, all these things will be done under the operation subsystem. So this is all the DSM architecture. So hope you understood it. So now let us take few assessment questions. Who sets the standards of GSM? Yes, ETSI sets the standards for GSM, Electronics Telecommunication System. Which of the following is the world's first cellular system to specify digital modulation and network level architecture? Yes, it is the GSM. Thank you for watching this video.